All right, welcome back, everybody. This is lesson 6 in GLSL for POPs and TouchDesigner. Today, we're going to be looking at the GLSL Advanced POP, or beginning to, and that's going to be a pretty exciting experience. So, let's get into it. I'm Blake Heckerman. I'm a new media artist. I explore how technology changes human perception. I think if you guys are here at this point in the course, you probably know me pretty well. So, I will skip past this. I'll skip past my past works. If you're interested in checking out more of this stuff, then definitely head over to my website. I just made an update, so there's some pretty cool content there to go check out all my past work. But for today, let's really just jump into things. We're going to look at the GLSL Advanced POP. And now, what is so interesting about this POP? Well, most POPs in TouchDesigner act only on one type of geometry, meaning primitives, points, or vertices. Now, the GLSL Advanced POP allows us to act on all of those things at once. And not only can we act on all of those things, or I guess because we can act on all of those things, we can also have access to all of the data coming from each of these pieces of geometry, and we can use that data together to create more complicated and sophisticated algorithms than we would be able to using the other types of operators available to us. It really truly unlocks everything on the GPU, and you've probably seen some pretty cool stuff coming from like Mini UV, especially using POPs, and a lot of the stuff that he's doing is using the GLSL Advanced POP to a very high degree. So that is probably the best like long-term example of what crazy stuff you can do using this operator. These two lessons are going to be focused on general usage, kind of understanding the flow, how to use these different point, vertex, and primitive data pieces together. And we are going to be working on a project example, but it's going to be way less flashy, let's say, than some of those examples because, well, there's a lot of complicated stuff to work through here. And so for at least our first couple lessons, we're starting not too intense. Okay, and then the last two important points here are one, the GLSL Advanced POP lets us write multiple output buffers, and those output buffers can easily have different dimensions as well, which is really helpful when you're doing simulations or a bunch of other stuff. And so that's one thing that we'll be looking at. And then finally, we can create geometry from scratch by literally creating primitives and line strips and things like that in the shader. So we're going to be looking at that also, although I will say, again, I am just scratching the surface of what this POP is capable of here. There will be follow-ups, but I want this course to be manageable, and also, heading into the holidays, I think a little bit of an easier lesson is better. So we're going to look at the Voronoi division algorithm. The reason for that is I think it's a really common algorithm. I think people know it really well and are very familiar with it. And so we don't have to worry too much about learning a completely new conceptual thing. We can focus more on the implementation aspect. So because of that, let's just briefly review what a Voronoi algorithm actually is. And then from there, we'll talk about the implementation of it. So the Voronoi algorithm consists of a set of sites that are projected onto the geometry, and then every piece of the geometry kind of decides which site it belongs to by evaluating which site is the closest. And so the boundaries that we can see here exist in regions, or rather exist in areas where the geometry, in this case triangles, are equal distances from two of the sites. And so that is what will form these cracked lines. And so our algorithm can be pretty simple. We can simply look at all of the geometry, project it onto a 2D plane, or just look at a quad that's already on a 2D plane. Find the nearest sites for every vertex. And then, based on those vertices that we associate to a site, we can classify whether each triangle created from those vertices is part of a crack or not. So, if all three of the vertices share a site, then we know that that triangle is going to be inside a region. But if some of the vertices of a single triangle do not share a site, then we know that that triangle is on a crack. And so that actually provides us a pretty easy way of evaluating on a per triangle basis what region that geometry is a part of, and therefore whether it is a crack or not. Pretty simple. The hard part here would be normally operating on vertices, but then kind of flipping back and applying the changes made from data derived from the vertices to the actual geometry itself, to the points. And so that's one of the things that GLSL POP will really unlock for us. So you can take a look at that. So here's an example of what we're going to be recreating in real time in TouchDesigner. We're going to read in geometry. We're going to iterate over all of the sites to find the closest site to each vertex. We'll then apply a different coloration to the triangles on the cracks. And then finally, and this is going to be a part 2, we're going to output completely new geometry to create these lines that are rendered over the cracks. Okay. So part 1 is going to be doing the Voronoi tile, and part 2 is going to be creating the new geometry, because I think it will be too long to do all at once. So that's what we're doing. That's where we're going. The rest of this tutorial is going to be available on TouchDesigner along with the project file for everyone on my Patreon. If you want to follow along, go subscribe there. Subscribing will get you access to this entire course, all the project files for all the lessons, all the exercises and solutions, and also all of the other materials such as GLSL 101 course and a bunch of other, like dozens of other TouchDesigner tutorials on a variety of topics. So go check it out. We can follow along from there.